All right, good morning. Hopefully you all had a good weekend and yeah, are ready to get back at this. Um, I was getting ready to record here and I was like, wow, I need to go get a haircut, but then I realized that barber shops are closed, so I have to attempt it myself. So that could be deadly, but we'll see that. All right, so for this morning's jokes, I have actually a couple pictures to show you. They're minion related. Hopefully you find them enjoyable. So I want you to do what this picture tells you to do because you won't get the same effect if you don't. Go ahead and read that there. Pause this video if you need to. I'm going to move on to the next picture. And lastly, there is one related to math that you might relate to. Square box, round pizza, triangle slices. I'm confused. Great. Hopefully that brought you some humor this morning. And we'll move right into the math lesson here. So lesson 86, and this is about volume of cylinders and pyramids. Actually, not cylinders, cones. Cones and pyramids. So I'm going to reiterate something to you that you already know, and that is how to figure out the volume of cylinders here and prisms or just regular shapes. Any object with whether it's a square base, a rectangular base, or triangular base, you know how to figure all that out. I'll just refresh your memory for that. So for the cylinder here, the base, or the way you figure out volume is you take the base times the height. You figure out how much area is in the base, which is a circle here, and then whatever the height is on that. So, and taking you back to figuring out what the area of the base is, you take pi times the radius squared. So if the radius here is 2, it would be 2 squared, which is 4 times pi. So your base would be 4 pi, and if your height is 10, you would have 4 pi times 10, which is 40 pi, 40 times 3.14. That's how you figure out the volume for the cylinder. For the prism, you take the area of the base times the height. It's pretty simple. And for the volume for that, you can do base times height. For this shape here, you could just do length times width times height, and that would also get you the volume. So, for example, here, if I put 5 and 8 for the base, you would take 5 times 8, that equals 40. And then if the height is also 5, 40 times 5 is 200. And that would be your volume for that. So that's old news. We learned that a while ago. So we need to switch to the next thing, which is the main idea of today's lesson. And so if I take this shape right here, and I just move it over, try to replicate as close as possible. So if I take a cone that comes to a point, but it has the same base as this, what fraction do you think this is of this shape? So if you turn this thing around, filled it up with water, and dumped it into here, how many times would you have to fill it up and dump it in to here in order for it to fill up? In other words, what fraction is this thing of this thing? If you had to take a guess, my first guess was probably about half because you have the same base and it just tapers off to a point up here. So I would have guessed about half. The same thing with this thing down here. So if you take this shape over here, and instead of making a rectangle for the base up top, you take all the corners to a point up top, make it a pyramid. For this one, I would have guessed somewhat the same thing as well, maybe a little bit smaller volume for this one than what I would have guessed for this one. So I would have guessed about 1/2 for this, and somewhere between 1/2 and 1/4 for this one. I'm actually going to do a little visual. That way you don't just have to look at the information in your book and be like, oh, I believe that. You can do this at home. it is a demonstration of actually how many times you have to fill this thing up with to get the volume of this thing. So if you give me a little bit, I'll set that up and show you what's going on here. All right, this is our lovely fern. As you can tell, it's only gotten worse since we haven't had school for so long. So I have a cone. It's made out of cardstock, and hopefully it doesn't disintegrate when it gets wet. And I also have a pitcher that's filled pretty much to the top there, you can see, with water. Now, if I set the cone right in front, see if you can see that, they're pretty much the same height. And this base right here is the same as this thing right here. So the drawing that I showed you on the board a little earlier, or just before this is going to prove how many times, I'm going to do it in reverse order. So I'm going to dump water into here and then dump it into the fern to give it water. So I'll dump it into there, and whatever your guess was. So if your guess is that, my guess was that this is going to be half of this. That means when I dump from water from here into this shape, it's going to take 2 of these filled to the top in order to empty this thing. If it takes 4, then this thing is 1/4 the size of this thing. So it should be pretty close. We'll go ahead and see what happens here. And actually, I'm going to have to quick make some minor modifications. I'm going to tape the base up here. Give me a little bit. Okay, no guarantee that this is going to survive this attempt. Looks like it's kind of falling apart. All right, here goes. All right, it's one full one there. All right, so that was one of these. We'll have to keep doing that till this thing's empty right here. That was the second one, and it looks like we have enough for a third one here. Whoa. All right, so 3 of these with a little bit to spare. So, like I said, they were close to the same size, but not quite. So what that means is that 3 of these, if I would do this in reverse order, which I guess if you want to, you can try and rewind the video somehow. If I would do this in reverse order, it would take, I would dump 3 of these into this thing. They're the same height approximately. 3 of these to get 1 of these. And so that means this thing is 1/3 of this thing. So we'll switch back to the main board and fill that fraction in. Okay, so what we learned there is that based off of the visual that I just showed you, that this shape right here, a cone with the same base as a cylinder, is 1/3 of this. So here's a little hint for you. Not a hint, but this is where it's going to end up at. So the volume for this thing, which is volume equals base times height, is the same thing as this thing, except you just plug this fraction in there. So the volume for this thing is equal to 1/3 of the base times the height, because these 2 bases are the same, their height is the same. It's just that when you fill this thing up, you have to fill this thing up 3 times, or it's only 1/3 of this thing right here. So it's just a visual illustration that the volume for a cone is 1/3 the base times height. Now, I don't have a pyramid to help prove this thing, but this one is the exact same. If you would make a printout and do the whole, exactly what I just did with that cone and water over there, this thing is also 1/3 of this one. So you have to ask yourself the question, what's the volume of this thing? Because their bases here are supposed to be the same and their height is the same. So you go ahead and figure out volume of this thing is equal to base times height. So therefore, just put 1/3 in. The volume of this thing is equal to its base times its height times 1/3 at the beginning. So nothing, pretty much what this lesson means is in order to figure out this shape and this shape, you throw 1/3 in the formula and figure it out that way. So let me get example 1 and 2 up here and we'll figure those out. Okay, so example 1. You have Aiden building 2 cones out of sand on the beach. So the smaller cone, the diameter is 6 inches and its height is 5 inches. Then he has a bigger cone and that is 12 inches, its height is 10. So it's twice the size of it as far as measurements go. It's asking the question, how many cubic inches of sand did Aiden use for each cone? So 2 separate cones, how much sand for each one? Then the follow-up question is how much times greater or how many times bigger is the volume of the larger cone than the volume of the smaller one? So compare the two, which one's bigger and by how much? Obviously it's gonna be obvious which one's bigger, but we'll go from here. So I have the formulas over here for your cone. 1/3 times base times height. The base is going to be pi r squared since it's a circle, and the pyramid is 1/3 base times height. So for this smaller one, the base is, so I'm just going to write this out because it's going to be easiest for you and for me to figure this out. So the base is pi r squared, so I'll write that pi. Radius is 3 because the diameter is 6. 3 squared times 5. Now, I think this, it tells you express pi as pi, so don't actually multiply it times 3.14, just leave pi in there. So we have to simplify this. 1/3 times 3 squared is pi times 9 there, so 9 pi times 5. So here you can do whichever step you would like. You can do 1/3 times 9, which is 3, or you can do 9 times 5, which is 45, and then divide by 3. Both of them come out to, so 1/3 times 9 is 3 pi times 5. 3 pi times 5 is 15 pi. So the volume for the first one, for this cone right here, is 15 pi. Now you might say, well, the second one's twice the size of it, so therefore it's going to be 30 pi. Well, if you remember, the area does not just increase by however much the numbers are increased, so the volume's definitely not going to do that. So let's look at this. Volume of the smaller one is 15 pi. So let's do the same thing with the next one. I'll draw a line down the middle. 1/3 times pi r 6, because it was the diameter is 12, the radius is 6 squared times 10. 1/3 times 6 squared, 36 pi times 10. Now again, you have the option. You can do 36 times 10, or you can do 1/3 times 36. I'm going to do that because it's a little easier for me. So 1/3 times 36, that means 36 divided by 3 is 12 pi times 10 equals 120 pi for the volume. So you compare the two. You have 15 pi for the volume of this one and 120 pi for this one. So it is not, this is not half the size of this one. It's not even close. 120 over 15. So the first part of the question is answered. We figure out the volume for both of them. The second part of the question asks, so how do they relate to each other? Which, the one that's bigger, how much bigger is it? Well, 15 times how many times? In other words, how many times could you stick 15 in 120? The way you figure that out is you put 120 over 15. You divide that out, and that gets you 8. 120 divided by 15 is 8. So the smaller one, you could stick 8 of the 15s in the 120. So that means the bigger one is 8 times greater, is the answer to the second part of your question. So just figure out the first one, the second one, and then compare the two. Divide, see how many times the smaller one could go to the bigger one to get your answer, which is this. Okay, let me erase some of this so it doesn't distract you from problem 2 here. So example 2, you're just supposed to figure out this shape here. It's supposed to be a square pyramid with a square base, and the way you figure that out is jump over here, 1/3 base times height. So what is how do you figure out the area of a square? The area of a square is side times side, or side squared. Area of a square is side squared. So what you're going to have to do is figure out the area of the base, which is 90 times 90. And I'm going to do this as 9 times 9 is 81, and then add the 2 zeros. So you have 8,100 for your base. Now, right here, you have to 1/3 times the base times the height. So you have a choice here. If I write this in 1/3 times 90 squared, or 90 times 90 times 50. So you can figure this out. And you can at any time. So I figured out 90 squared first of all. Now I'm going to multiply that by 1/3, which is just dividing it by 3. So 81 divided by 3 gets me 6, 21 is 7, and then 2 zeros. That comes out evenly. So 1/3 times 8,100 and 90 squared is 2,700. So let me just write this out for you. So you have 1/3 times 8,100 times 50. Moving over to here, 1/3 times 8,100 is 2,700. So 2,700 times 50 is the next thing that you have to do to figure out the volume. 2,700 times 50, 27 times 5 is, oh boy, 35 and 13, and then add. So what I did there was 27 times 5 equals 135, and then you add the 1, 2, and 3 zeros here. And that gets you the volume of, realize something, that gets you the volume for this pyramid here, which the measurements are centimeters, and since it's volume, it's cubed. So the volume is equal to 135,000 centimeters cubed, which I forgot to do that over here. This would have been cubed, and this one would have been as well. So make sure you keep that in your measurements. Now, let me see if that's the right answer for example 2 there. Yeah, 135,000 centimeters cubed. It may seem like a lot, but if you take if you take a centimeter, nope, that's not a centimeter measurement, but if you take a centimeter, it's about this big, and make a cube out of that, you could probably, well, you could very easily stick that in this one if true to scale, because 90 centimeters, they're big numbers, but they're small measurements. Okay, then the last one, example 3, is more of the same here. You have a pyramid here, except it has a triangular base now. We have a square base up here. This is a triangular base. They tell you that the height is 10. They also tell you that the base is 36 times the square root of 3 units. And the way they figured it out, they have that drawn out here. You would do 1/2 base times height, which 1/2 times the base is 12, 1/2 of that is 6, and then 6 times 6 times the square root of 3. You do 6 times 6 because both of those are outside the radical sign, and you get 36, and then you have that radical form there. So this is the base. They tell you that already, but that's how you figure that out. So 36 times the square root of 3 is your base. Your height is 10. Now let's jump back over here. This is still a pyramid because it's a shape and it comes to a point at the top. The other time it's a cone is when it's a circle. So 1/3 the base times the height. So let's write that problem out. 1/3 the base is 36 times the square root of 3 times the height, which is 10. So at this point, you can figure out how in the order that you want to because they're all multiplying. So you could do 36 times the square root of 3 times 10, or you could do 1/3 times 36. So it's 36 divided by 3 or 36 times 10 and then divided by 3. I'm going to do this route. 1/3 times 36. In other words, 36 divided by 3 is 12 divided, or 12 times the square root of 3. So 36 divided by 3 is 12, and the square root of 3 times 10. Again, just remember that you cannot do anything with this unless you have another number that's in a radical sign. So what you're going to do here is you're just going to multiply 12 times 10, which is 120 times the square root of 3. And what are the measurements that they give you? I don't think they give you that. So your answer is volume equals 120 times the square root of 3, whatever their measurements is, it's inches cubed, be the correct answer there. And so that's where it becomes useful. You just leave that radical sign in rather than actually figuring it out there. Okay, I'm going to do a couple practice set problems here, and then I will be done here. Okay, practice set A. So what it tells you to do, it says look at example 2, the pyramid in example 2, which is the same one, and this was the answer from example 2, that's in your books. And it asks you the question, find the volume of a pyramid with dimensions 1/10 of the pyramid in example 2. So example 2 had measurements of 90, 90, and then the height was equal to 50. Well, ask yourself the question, what is 1/10 of this? Well, you just take a 0 off of all the numbers. So instead of 90, 90, and 50, you now have 9, 9, and 5. So what is the volume? The volume is equal to the base, 1/3 times the base times the height. So the base is what? 9 times 9 gets you the area of the base. So 81 for that. The height is 5 and 1/3. Volume is equal to 1/3 times 81 times 5. 1/3 times 81 is the same thing as 81 divided by 3. 81 divided by 3 is 27. So 27 times 5, and that equals 135 for that. So the volume is equal to 135 for this one. And if that's wrong, correct me on your own. I think that's accurate. So this is 135, and example 2 was 135,000. So what it asked the question, the volume of the smaller pyramid is what fraction of the volume of the pyramid in example 2. So it's not asking how many times bigger, but it's asking what fraction is this of this. And the way you do that is you just put it in a fraction, 135 over there, and you're supposed to figure out what is the fraction here. And what you can actually do is, so what this would be is if you move the decimal point 1, 2, 3 places, and move the decimal point 1, 2, 3 places, it's 135.135 over 135. But I think this actually reduces down to, hang on here. Okay, so this actually reduces down to 0.001 if you actually divide it out, which 0.001 is 1,000. So what fraction is the smaller one or the bigger one? Comes out to 1 over 1,000 for that. So there you have that information. Okay, practice set B here. 1/3 times base times height. They give you something for crazy pyramid shape there. And the base, they give you already 18 times the square root of 3. The height is 12. So they're asking what is the volume of it. Go ahead and figure this out. 18 divided by 3 is 6. 6 times the square root of 3 times 12. 6 times 12 is 72 times the square root of 3. The volume is 72 times square root of 3. Whatever their measurement is, I'm going to use inches again, cubed. So that's what you have for that. I'm going to skip and jump to D and E. The nice thing about these two is that you really don't have to use any formulas or anything to figure this out. So D, he has, if you look at the shape there in the book, he has a 12-inch cube of clay. So it's 12 inches by 12 inches by 12 inches high. And he makes a pyramid that has a 12-inch base, and it's 12 inches high. And you're supposed to figure out the volume of that. So it's base 12 times 12, 144 times height. Volume equals 1/3 base times height. The base is 144 times 12, which is 1/3. So you can ask yourself a question, figure that out, which is, oh boy, 144 divided by 3. It's quick. That's 48. So 48 times 12. Go ahead and figure that out. That would give you your answer. We can figure that out here. So this should be 576 is what I get for my answer, inches cubed. Yeah, that one, 576 inches cubed. Now, it asked the question, does he have enough clay from the original cube? So he took that pyramid out, and then he was wondering if he can make another one, which you know that if you have a regular shape and you take a pyramid out of that, you only took 1/3 out. So if he wants to make another one, he could. If he wants to make 2 other ones, he could. He can make 3 pyramids out of that block of clay. Letter E then, you have a party hat in a cylinder container, and it fits perfectly. So obviously it works with our equation that we have. If the volume of the container is 99, what is the volume of the hat? Well, if the container, which would be this right here, if the container equals 99, and you put the 1/3 in there, what is 1/3 of 99? It would be 33 inches cubed. Perfectly there. So that's how you figure that out. Again, let me know if you have questions, and that is